everyone, this is Anand from his Academy. Today we're going to solve the Additional Mathematics 4037 paper 1-2 of the October-November 2024 session. So let's get started. Question number 1. The curve y equals to a cos bx plus c, where a, b, c are integers, passes through the points minus pi by 6, comma, minus 2, and pi by 9, comma, half. The curve has a period of 2 pi by 3. Find the values of a, b, c. Okay, so the first thing that we need to look at is the period, okay? So the period is given. We know the formula that the x coefficient is given by b equals 2 pi by period. That's the formula that we're going to use. Or you can write it as b into period equals 2 pi. Okay, so the coefficient of x and the period multiplied together always gives you 2 pi. So we can subject b and then plug in the period, and once simplified, we find that b is equals to 3. Okay, then we take one of the points that is given, minus pi by 6 and minus 2. We input these values over here, and we form an equation, and we find that c is equal to b minus 2. So that's using one of the points. And then with another point that is given, we can use it to find a. So how can we use it to find a? We basically input all of these values over here, x equals pi by 9 and y equals half, into our equation over here. So once we are done with that, we input the value of c. C is found to be minus 2, and a is unknown, and your y is equals to half, and b is equals to 3. Once we input all of those values in and subject a, we find a to be equal to 5. Number 1b. Find the least value of y on the curve for x greater than 0 and greater than or equal to 0, and less than or equal to pi by 2. State the value of x at which this occurs. Okay, so to look at this question, to solve this question without anything but without a graph would be very difficult. So what I've done here is drawn a simple sketch of the curve. So here our amplitude is 5, our period is 2 pi by 3, and our curve moves down a place of 2 places. So the curve will have a midline of minus 2. It will have a maximum value of positive 3 because 5 minus 2 gives you positive 3. And it will have a minimum value of minus 5 minus 2 that will give you minus 7. Okay, so the halfway point of this curve, or the time taken, or the x value at which the minimum point occurs is 1 by 3 pi, because that's half of 2 by 3 pi. So as I was saying, the minimum point occurs at the half point of the period, because that's how the cosine curve is designed, or that's how the cosine curve is in its nature. It's like that because the full period is 2 pi and halfway point is pi. So if it's 2 by 3 pi, the halfway point would be pi by 3. Okay, so we know the x value, so we write that down. X equals 1 by 3 pi. What's the minimum value? The minimum value is simply minus 5 minus 2, and that's minus 7. And that's over here given. And since this value lies within 0 and pi by 2, we can include this value. Question number 2. It is given that y equals f of x, where f of x equals twice x minus 5 times x minus 1 whole square. Part A. Find the coordinates of the stationary points on the curve y equals to f of x. So we write the f of x down over here. To find the stationary point, we first need to find the derivative, or f prime of x. To do that, what we will do is we will use the product rule. So we first write down the first part of our function, and then differentiate the second part of the function, which is being multiplied. Then we add the second part over here, multiplied by differentiation of the first part over here. So that's the product rule basically. Once we simplify, we get this over here. For the curve to be stationary, we need the f prime of x to be equal to 0. So we put all of this over here to be equal to 0. All right. So once it's equal to 0, what we can do is we can take x minus 1 common. As you can see, it's a common term between these two terms. And once we simplify, we see that it's x minus 1 times x minus 3 twice x minus 6 is equal to 0. So x is either equals to 1 or x is either equals to 2. So once we input that into our y equation, we find the coordinates to be 1, 0, and 2 minus 1. Okay. On the axis, sketch the graph of y equals f of x, taking the intercept with the axis. Okay. To find the roots of this equation, what we need to do are the x-intercepts with this. First, let's find the x-intercepts of the function. To find the x-intercepts, uh, we need to equate this function to be equal to 0. So we find x to be equal to 5 by 2 or x equals to 1. So that's one of the, so those are two of the, so let's mark those 2 points with our red pen. So these are the 2 points that are the intercept. The y-intercept is simply given when when we when we make this equal to 0 over here, which where's my pen? Okay, when we put x equals to 0, and that gives us 5. So y-intercept is 0 minus 5. Okay, so not 5, minus 5, because when we put x equals to 0 over here, it's being multiplied by minus 1 whole squared. So that would give you minus 5 times 1 and minus 5. So we mark that point as well with our red pen. Then we look at our equation over here and see whether the coefficient of x cubed is positive or negative. Because if it's positive, then the curve will go like this. If it is negative, then the curve will go like this. We can see that there are no negative terms over here. So if we expand this out, we get x squared plus something, something, something. Sorry, minus x squared minus something, something, something. And this is twice x, something, something, something. And then that multiplied gives us twice x cubed. Since the coefficient of x cubed is positive, we will get a curve like this. It is also wise to notate or to uh, mark down the minimum points as well. So these two are the minimum points. We mark that down. And since the coefficient of x cubed is positive, we will draw a curve like this. This is what we will get. Okay. Next is, hence find the values of k for which f of x equals k has exactly one solution. So what does f of x equals k exactly mean? F of x equals k means that we have a straight line going from a straight horizontal line that cuts the curve into in at different points. Okay. So this line over here can move. Okay. And for what values of this k are we getting only one solution? So let's see. Here we have 4 solutions over here. Okay, 4, 4, 4. Here we have 2 solutions because one is a tangent point and the other one is an intersection point. Here we have 2 solutions as well. But once we go over this point, we get one solution. And once we get under this point, we get one solution. Here we get 4 solutions again. 4, 4, 4, 4, 2, 1. 4, 4, 4, 4, 4, 2, 1. So it's below minus 1 and above 0. So our values of k for which the f of x equals k has exactly one solution is k is greater than 0 or k is less than 1. Okay. Question number 3. In this question, all lengths are in centimeters and all angles are in radians. Okay. So the diagram shows a circle with center O, radius 12, and a circle with center C and radius 5. Circles intersect at points AB such that OA and OB are tangents to the circle with center C. show that the obtuse angle ACB is 2.35 radians corrected 2 decimal places. Okay, so here we have a diagram. We have two circles which have center O and C respectively. The radius of the larger circle is 12. The radius of the smaller circle is 5. And we need to find the angle, um, what angle? ACB. So this large angle over here. So what we can do is we can consider triangle AOB over here. It is a right angle triangle because the tangent over here at uh, at circle A, at point A, makes a right angle with the radius. That's one of the circle theorems. So we first let ACO be equals to theta degrees. So what we can do is we can consider this right angle with theta angle over here. And we can use tan theta, which means opposite, which is 12 centimeters, over adjacent, which is 5 centimeters. And we find theta to be 1.1760 radians. Therefore, ACB is equals to 2 times theta. That's we know from symmetry. So 2 times 1.760 gives you 2.35, 201. Therefore, ACB equals to 2.35 radians. Now they told us to find the perimeter of the shaded region. So what is the perimeter of the shaded region? We know the perimeter of the shaded region are these two radii in blue. These two radii over here. These two radii. This arc length over here. This red arc length. So this gives us the shaded perimeter. So simply the shaded perimeter would be AO, which is one of the radii, plus BO, the other radii, plus arc AB over here. All right. So how can you find the arc AB? We simply use arc length equals arc theta. That's one of the formulas for circular measure. So which circle are we using to find this arc length? We're using the smaller circle. So we will use R equals 5. And what angle are we using? It's the ACB. Here, we take the angle to be more than, to be greater than 2 decimal places, because that would give us a more accurate answer in the final answer. Once we solve this, we get the shaded perimeter to be equal to 35.8 centimeters. Part C, find the area of the shaded region. So to find the area of the shaded region, we need to take a look at some parts of the shaded area. So we have, first of all, we have these entire two triangles that are in green. So this entire triangle, these two triangles cover up one part of the area. Okay, sorry, I'm back. Had some technical difficulties. So the second area that's covered by the second area that we need to look into is the sector area, which is in yellow, right over here. So the shaded area over here is simply given by the 2 times the triangle area. So our shaded area is 2 times triangle area minus sector area. And that is our shaded area. So shaded area is over here 2 times AOC, which is the triangle, minus sector AB. So 2 times AOC is 2 into half into base into height. And the sector area is minus half r squared theta. That's one of the circle theorem formulas, half r squared theta. And the shaded area is found to be 30.6 centimeters squared. Question number 4. The function f is such that f of x equals 4 natural log of 3x minus 2 for x greater than a, where a is as small as possible. Write down the value of a. So we know that a logarithmic function has a general shape like this. We see that the x part of ln x is always greater than 0, because that's how the graph goes. So this entire part over here, thrice x minus 2, has to be greater than 0. And once we subject x, we find x greater than 2 by 3. Therefore, a is equal to 2 by 3. All right? Write down the range of f. So if we look at the graph of ln x, general graph of ln x, we see that the y values of x goes from negative infinity to positive infinity. So it covers all the real values of y. So if it covers all the real values, then f of x is an element of R. So that's how you write down the range of f. Okay. Find f inverse of x, stating its domain and range. Okay. So to find the to find the f inverse of x, we first need to write down y equals f of x. So we let y equals to be f of x. Then we swap the x with the y. So y becomes x and x becomes y. Then we subject y and we find y to be equal to e to the x by 4 plus 2 by 3. And that's f inverse of x. Now the domain of x would become, so how can we find the domain of x? The domain of x would be the range of f, because for f inverse of x, the domain and range get flipped. So the domain of f inverse of x would be the range of f of x. So it would be x is element of R. And the range of f inverse of x has to be equal to the domain of f of x. So range is f inverse of x is greater than 2 by 3. And that's it. Part 4. On the axis, sketch the graph of y equals f of x and y equals f inverse of x, stating the intercepts with the axis. So first we can draw the logarithmic function, as we know. That's how our um, graph is first given. It's wise to draw f of x first and then f inverse of x. So f of x is simply a logarithmic function. And to find out whether f of x intersects with y equals x line, we can do a simple calculation using a calculator. So for ln x thrice x minus 2 is equals to x, we can input this in our calculator, and then you can use the calc solve function to find the intersection points. We can do it for a smaller value of x, which is greater than 1, and we can do for a large value of x, which is like, say, greater than 5. If it shows two intersection points, then we will show two intersection points over here. And f inverse of x over here will also intersect with f with y equals to x, as it's a mirror image on the y equals to x line. Therefore, it will also have two intersection points on the line. Part B. Given that g of x equals to 2x plus 1 to the half plus 4 for x is greater than 0, solve the equation g of x equals 9. So g of x equals 9 basically means g of x is input into g of x again, and that's all equal to 9. So if g of x is input into g of x, that would mean 2 times g of x plus 1 to the half plus 4 equals 9. So we simply solve for g of x, and we find that g of x is equals to 12. Now we write g of x as is, twice x plus 1 to the half plus 4. Then we solve for x, and we find x to be 31.5. Pretty easy. Question number 5. Show that 1 plus cotangent squared of theta over cotangent squared of theta equals to secant squared of theta. So first we will choose the left-hand side. Then what we will use is we will use this identity over here. 1 plus cotangent of squared of theta. Okay, I wrote x over here. It should be theta. That's my mistake. It should be theta. All right. So 1 plus cotangent squared of theta is equals to cosecant squared of theta. So we simply write that over here. Then we break down our trigonometric function. So cosecant squared of theta is a reciprocal function. It's simply 1 over sine squared of theta. And cotangent squared of theta is simply cosine squared of theta over sine squared of theta. But since it's in the denominator, it will get flipped once you put it in the numerator. So it would become sine squared of theta over cosine squared of theta. The sine squared theta gets cancelled out, and we are left with 1 over cosine squared of theta, which is simply secant squared of theta, as that's the reciprocal function of cosine squared. And that's equal to the right-hand side, and we are done. Write down the part B. write down the derivative of tan theta with respect to theta. So the derivative of tan theta is simply secant squared of theta. That's what you need to know. It's very simple. Okay, using part A and part B, find the exact value of the integral of 1 plus cotangent squared of theta over cotangent squared of theta minus sine theta from 0 to pi by 3. So we found that this over here is equals to secant squared of theta. So we can put that over there. And this sine theta is, let's keep it as is because we can integrate that easily. The integral of secant squared of theta is simply tan theta. As we know that secant squared of theta is the derivative of tan theta. So if we take integral on both sides, we see that secant squared of theta is equals to tan theta. The integral of secant squared of theta is equals to tan theta with respect to theta, of course. Okay, so the integral of minus sine theta is plus cosine theta. That's what we should know. We input our value of theta, which is pi by 3, and then we input the value of 0 as well. And then we find the value to be 1 plus 2 root 3 by 2 minus 1. Once we put everything together, we find 1 minus 2 root 3 over 3. And then if we distribute the half over the two terms on the numerator, we get root 3 minus half. And that's it. Question number 6. Find in descending powers of x the first three terms in the expansion of x plus 2 over x squared whole to the 10. Simplify each term as far as possible. Okay, so we can use the binomial theorem over here. What the binomial theorem says that it's if anything a plus b is raised to the power n, then we get a to the n plus n, a to the n minus 1, b plus n c2, a to the n minus 2, b to the 2. Here it will be nc1, but since nc1 is n, I simply wrote it as n. So what we do is we simply follow that rule. We first raise x to the highest power. Then we take the first binomial coefficient of 10c1, and that's simply equals to 10. We decrement the x's power by 1, and then increment twice x over x, sorry, twice over x squared. We increment that to the first power. Then we take the second binomial coefficient, which is 10c2, that's 45. Raise x to the 8, and raise twice 2 over x squared to the second power, and then so on and so forth. Once we simplify everything together, we find the first three terms to be x to the 10 plus 20x to the 7 plus 180x to the 4. And that's our answer. Part B. Find the term independent of x in the expansion of 4x squared plus 1 over twice x squared whole to the 8. So to do this, what we will need to do is we will need to take into account a general term. So a general term basically is a binomial term, which is in terms of r and in terms of x. So the general term is 8cr, 4x squared to the 8 minus r times 1 half x to the minus 2 to the r. I took x to the minus 2 by simply moving the x squared to the numerator, because that would make our workings much easier. How did this entire thing come from? This came from the general term of the binomial theorem, which is n choose r, a to the n minus r, b to the r, where a here is 4x squared and b is half x to the minus 2. Okay, we separate the 4 and the half and accumulate the x's together to find x to the 16 minus 4r. How did we find that? Okay, so once we distribute this x to the x squared, we get x to the 16 minus 2r. And since we have here x to the minus 2r over right here, by simply, distributing this over here, our final x term becomes x to the 16 minus 4r. So for this entire thing to be independent of x, we need this term over here, this power over here, to be equal to 0. Because anything to the 0, or anything but 0 to the 0 is, anything to the 0 is equals to 1. Anything mean anything but 0. Okay. So once we simplify that, we find r to be equal to 4. And then we simply input this 4 into our equation. Since x is is raised to 0, that gets nullified. And we are find our final term to be equal to 1120. Question number 7. It is given that y is equals to L natural log of twice x squared minus 1 over x plus 2 for x is greater than 1 over root 3. When x equals 1, y is increasing at a rate of h units per second. Find in terms of h the corresponding rate of change in rate of change in x, giving your answer in exact form. So we need to find it in exact form. We cannot use any we cannot have any decimals or any reduced fractions. Not reduced fractions. I mean anything in decimals. So so what is given? Let's take a look. So the thing that's given is dy by dt, and that's h units per second when x equals to 1. And we need to find dx by dt. How can we do that? We need to first, excuse me, we need to first find the derivative of y with respect to x. How can we do that? We can use the quotient rule. What the quotient rule says that we will raise the numerator to the second power, then bring it to the top, and then multiply it with the differentiation of the top part minus the top part times the differentiation of the bottom part. Once we solve that using our quotient rule, we find our dy by dx to be equal to this. And since we are taking a look at of dx by dt at x equals to 1, we need to find the dy by dx at x equals to 1. So at x equals to 1, we input this 1 over here into our dy by dx. We find dy by dx to be equal to 9 minus natural log of 2 over 9. To find dx by dt, we simply multiply dy by dt with the inverse of dy by dx, or dx by dt. What happens here is the dx's get the dy's get cancelled out, and we find dx by dt. And once we do that, we finally find our answer of dx by dt to be equal to 9h over 9 minus ln of 2 units per second. Question number 8. The tangent to the curve y equals e to the x times twice x plus 5 to the half at the point where x equals to 2 meets the x-axis and at the point x and at the y-axis at the point y. Find the coordinates of the midpoint of xy, giving your answers in exact form. So to find the tangent, the equation of the tangent, what we need to do is find dy by dx first. So how can we find dy by dx? We can use our good old product rule, simplify that, and find dy by dx to be equal to e to the x over twice x plus 5 to the half plus e to the x times twice x plus 5 to the half. So when x equals to 2, we find our dy by dx, or the gradient at x equals to 2 over here, to be equal to 10 by 3 e squared. And when x equals to 2, we find our y value to be 3e squared. And the equation of the tangent is simply given by y minus y1 equals to n x minus x1. So we know our y value is minus 3e squared. We know our n value, which is 10 by 3e squared. And we know our x value, which is minus 2. Sorry, which is plus 2, and this being minus over here. Once we simplify that, we find our equation of tangent to be 10 by 3e squared x minus 11 by 3e squared. And when and let's find the x coordinate first, or the x point over here. So it meets the x-axis at point y. That means y has to be equal to 0 at that point. So we find our x value to be 11 over 10. And when x equals to 0, that means the y-intercept, we find the y-intercept to be minus 11 by 3 e squared. And that's our y point. The midpoint is simply given by the average of the 2 points. So we average these 2 points over here. So after averaging, we get the midpoint of xy to be 11 over 20, comma, minus 11 over 6 e squared. And that's it. Okay, question number 9. The diagram shows part of the curve y equals to 4 over twice x plus 1. In the straight line, twice y equals to 6x plus 1. Find the area of the shaded region, giving your answer in the form ln a plus b, where a is an integer and b is a rational number. So to find the integral first, we first need to know the upper bound and the lower bounds of our integral. So the lower bound, as we know, we can see from the diagram, is 0. And the upper bound is something that is greater than 0. To find the upper bound, we simply have to equate this entire thing in these two equations together. We have to equate them together to find the intersection point. So if we equate these together and solve for x, we find x to be equals to half or minus 7/6. Since in the diagram, x is shown to be positive, we don't take the negative value and we only take the positive value. That is all for the finding the upper bound. Now, since we found the upper bound, we can now find the shaded area. So let's take a closer look at what we're finding here. So what we're finding here is this area over here. So this area that's covered by the curve, this area over here that's covered by the curve, and the second area that's being covered by the line. Excuse me for that. Let me make it keep a bit smaller. Yeah. And the second area that's being covered by the line, that's under the line. So our shaded area is simply the yellow area minus the green area. So how can we solve that? We can simply integrate 0 to half of the curve minus 0 to half of the line. Here, the line is given to be twice y equals to 6x plus 1. We need to find it in terms of y. So we divide both sides by 2, and we find y to be equals to twice x plus half. Twice x plus half. Twice x plus half. Y equals to, of course. All right. So if y equals to twice x plus half, we can integrate this. This is the simple rational function where the integral of any rational function of a of 1 over ax plus b is simply given by 1 over a ln of absolute value of ax plus b. So if we can take the 4 out and we can find the integral of our natural function. And this is a simple polynomial that we can just raise the power to 1 and divide by the reciprocal, and then equate that. We simplify it further. We can bring the 4 inside, and then it becomes 2 ln of twice x plus 1. We input our values. So first we put half, which is equal to 2, and then we equal to 0, which is equal to 1. And then first we equal half over here, and then input 0, which is equal to 0. And once we simplify, we find the area to be natural log of 4 minus 5/8. And that's it. Question number 10. The first three terms of an arithmetic progression are 2 tan x, 2 tan of twice x, 5 tan of twice x, and 8 tan of twice x. Find the values of x where x is greater than or equal to negative 180 and less than or equal to 180, for which the sum of 30 terms is 455 root 3. We know that the first term is 2 tan of twice x. So the common difference of this arithmetic progression would be the second term minus the first term. And that gives us 3 tan of twice x. We can also use the third term minus the second term, and that will give us the same value. We use our arithmetic progression sum formula, where n by 2 times twice a plus n minus 1 into t equals to sum of n, where n is the number of terms, a is the first term, and d is the common difference. We simply input all of the values over here, and we get a singular value over here, where tan twice x equals to root 3/3. So since tan twice x, the inside is the x is being multiplied by 2, our new range would be minus 360 to positive 360. So for the positive term, we get the first quadrant and the third quadrant. And for our negative term, we get the second quadrant and the fourth quadrant. So let's take a look at our negative answers first. So the fourth quadrant is simply given by, so first let's find the basic acute angle. We can just use our calculator to find the basic acute angle, tan inverse of root 3 by 3, and that's given to be 30. And then twice x would be equal to minus 360 plus 30. That's this part of the quadrant. Then minus 180 plus 30, that's this part of this quadrant. Then just 30, that's the first quadrant. And then the third quadrant, that is this part over here, and that's 180 plus 30. And our answers are found to be these values over here. Minus 165 degrees, minus 75 degrees, 15 degrees, and 105 degrees. Part B. The first three terms of a geometric progression are as follows over here. Find the values of theta for which the geometric progression has sum to infinity. Okay, so to find the values for theta for which this has a sum to infinity, we need to first find the first term and the common ratio. For arithmetic progression, we had common difference, but for a geometric progression, we have a common ratio. So our first term would be a cosine squared of theta minus pi by 2. And the common ratio would be the second term divided by the first term. We can also use the third term divided by the second term, and that would give us the same answer of 4 cosine squared of theta minus pi by 2. And our new range over here would be 2 minus 2 pi by minus 2 by 3 pi. Theta minus pi by 2 is theta minus pi by 2 is greater than minus 2 by 3 pi and less than or equal to 2 by 3 pi. Okay, for the series to have a sum to infinity, the absolute value of the common ratio has to be less than minus 1, or the common ratio has to be greater than minus 1 or less than 1. So the common ratio over here is given is 4 cosine squared of theta minus pi by 2. This has to be between minus 1 and 1. As we know that the squared trigonometric functions are always greater than 1 because they're squared. The negative parts are being multiplied with each other. That's why we get a positive value always. So the only part that we will be interested in is this part. So we simplify that. This is a quadratic inequality, and we need to find the critical values of cosine theta. So the critical values of cosine theta minus pi by 2 is plus minus half. Okay, so we equate this to be equal to minus half. We find alpha to be pi by 3. We know that our range is from minus 2 by 3 pi and less than 2 by 3 pi. So we take these values of negative values and the positive values as well. Okay, I think we missed one of the values. One of the values should be, as I was saying, we missed one of the values, and one of the values was minus pi plus pi by 3. That happens when we are taking a look at the negative quadrant. Okay, so when we're taking a look at the negative quadrant, we see that it's in the second quadrant. So second quadrant of the negative value would be minus pi plus pi by 3. And once we take a look at the positive part, we find pi minus pi by 3. This happens because in quadrants 3 and 4, or 2 and 3 for the negative part, cosine of theta is negative. So quadrant second and third are the quadrants where cosine theta is negative. That's one part. The second part is cosine theta minus pi by 2 is equal to half. So that happens in the negative quadrant as well, because we were taking a look at minus pi by 2 pi by 2 by 3 pi as well. So so we get the values minus pi by 3 and pi by 3. So these are the two values that we get. And once we subject for theta, we find our values to be pi by 6 and 5 by 6 pi. Now, the second part of this problem would be to draw a simple curve. So how to draw this curve over here is this cosine curve over here. To draw this cosine curve, we need to first look at this part over here. So theta minus pi by 2. The curve is being shifted to the right by pi by 2 units. So the cosine curve essentially becomes a sine curve because it's being shifted to the right by pi by 2 units. Then we input our values for which cosine is equals to minus half and half. So minus half is over here and plus half is over here. So it's equal to minus half at minus pi by 6 and pi by 6, as we know, we found out from our calculations over here. Minus pi by 6 and pi by 6. And then also at 5 by 6 pi and 7 by 6 pi. Then we take a look at for the values for which these for the curve is between minus half and half. So it's this green area over here for which the curve is equals to minus half and between minus half and half. And it's between these two values for which the curve is also equals to half and minus half. So our final values for theta for which the curve is within these values is pi by 6 is theta is greater than pi by 6 and less than pi by theta is greater than pi minus pi by 6 and less than pi by 6, or theta is greater than 5 by 6 pi and less than 7 by 6 pi. All of this is excluding 0 because for that all of these are excluding 0 and pi because then we would get cosine to be equal to the common ratio to be equal to 0, and we can't have a common ratio equal to 0 because that would not make a geometric series and our sum to infinity would be invalid. So it's excluding 0 and excluding pi. Okay, that's it for this paper. Thanks for watching. Tune in for more videos in the future. Bye bye.